Well, good morning. Hope everyone's having a good build. It's last day, almost there, home stretch. So my name is Tony Champion. I'm a Microsoft MVP, been an MVP for about 8 years now. Over the years, I've had an opportunity to work on several different UWP projects, some large, some small. And through those times, we've had some various challenges, and it's kind of what we're going to talk about here today is, building UWP apps and targeting for multiple devices. All right, so I just out of curiosity, how many UWP developers I have in the room? See, this is why I love Build, because it's so much more than most of the time I give these talks, so I like it. All right, so before we get into the meat of this, we need to talk about this kind of question I would like to bring up is what is a Windows developer? And the reason I bring this up is because it's changed over the years. And the size and scope of kind of what a Windows developer is significantly different than 5 years ago, 10 years ago. So a Windows developer used to write on these, right? You wrote applications to run on desktops and potentially laptops, but other than that, that was it, right? It was VB6, it was WinForms, it was WPF. But as a Windows developer, you wrote for the desktop. Right? And so there's other devices available at the time. There's Windows CE, there's Xbox and Xbox 360. But as a Windows developer, you didn't target these. You didn't target them because they were different environments. The OS was different. Yes, it was Windows, but the OS was different. The tooling was different. Everything about it was different. So if you're a Windows CE developer, you wrote for Windows CE. You didn't typically bounce back and forth. You saw very few people that were cross-platform of all three of these. So fast forward to Windows 10, and now we have something different, right? Now we have a common core that runs across all of Microsoft's devices. You have Windows 10s on everything, on Xbox now. You've got it on HoloLens, IoT devices. You have Windows 10 running across all these devices. And on top of that, the number of devices keeps growing. Right? And they keep growing and growing, and we see new devices all the time, so that we had to actually kind of group these into device families. So now, as a Windows developer, my scope has changed. Right? So now, if I can write UWP apps for a Windows desktop, I can also write them for Xbox. I can write them for HoloLens. I can write them for IoT devices. Anything that runs Windows 10, I can now write apps for. So now the size and scope of my responsibility has changed. And it's something to consider when you go into some of these projects that now we can target an awful lot more devices than we used to in the past. With that, we get to find the Holy Grail, right? The one app to rule them all, right? That's just every developer is looking at it, that can we write it once and run it everywhere? So of course, this is just Microsoft Windows 10 devices, but yes. So as a Microsoft Windows developer, we can write one app run across the entire network of all the devices. So since the topic of this talk was build UWP apps for multiple devices, we just solved it, we settled it, quickest build talk ever, right? We're done. You write it, deploy it, and that's all there is to it. So the thing that we need to consider though, and I use this with developers all the time, and actually as developers we're horrible at this. Just because you can doesn't mean you should. And I talk about this because it needs to talk about our scope of responsibility. And developers are horrible about this, right? We get the shiny object syndrome, something new comes out, and we're like, ooh, this is exciting. I need to put this in the app, or it's a new framework. Let me just completely rewrite this app to use the new stuff. Well, why are you doing it? I don't know. It just would be cool to do it, so let's just do that. And as developers, when you start talking about UWP and start talking about multiple devices, it has to be a conscious decision, right? You need to actually do some consideration on why you're trying to target multiple devices. I don't know, how many people have, there's still gotta be somebody in this room who's done this. How many times you walked into a project, new contract, new job, look at this software, and within a couple of days go, you know what? I could rewrite this. I can do this better, right? It falls in the same concept of just because we can doesn't mean we should. And so I have this conversation over and over with people, and it brings up the conversation of responsibility of development. Because you'll see another thing that's different now than what it used to be for Windows developers, especially all developers, is now we have this whole concept of responsibility. And we started off the conference with that in the keynote, talking about responsibility as software developers and software engineers. And you could go into an entire talk about the whole scope of the responsibility, but what I want to talk about here is that the bottom line is today, in today's world, we have a responsibility to all of our customers, whether internal or external, it doesn't really matter, to provide a good user experience. So the decisions you make when you create when you go through and create an app, they have to be considerate. They have to be for a reason, right? You're not just doing just because. Does it give the user a better experience? And if it doesn't, then you don't need to do that. So a couple examples. You create an accounting app, right? You create it on desktop, and the great thing about desktop apps is that you have a ton of extra space, right? You can put a dense UI in there, you can put a lot of information on there. Up and running, it runs well, but does it run well on HoloLens? Is there a reason to put it on HoloLens? Now, I was thinking about this the other day. I was talking to somebody about this example, and yes, I know for all my Uber geeks out there, you're thinking, okay, well, now I could probably create a HoloLens app that was some kind of accounting app that does some kind of expense tracking or something that'd be awesome. But for most cases, you can't really do that. It doesn't fit. Jump over to IoT. So you have an IoT device that measures rain. Now, the UWP app that runs on an IoT device, its whole job is to collect sensor data and push up to Azure. That's the whole thing it does. Does that app run on the Xbox? Well, it could, but what is it going to do? And again, you can kind of follow that scenario. Well, we can create an Xbox app that does some amazing stuff, does real-time analytics, tracking rain charts, and doing all kinds of graphics. It'd be great, and it's awesome. But is that the same app that runs, UWP app that runs on the rain sensor collecting data and pushing it to Azure? And so the whole thing is just basically trying to get you to the point of understanding that you need to make a decision on why you're targeting multiple devices. So let's assume that we've gone through that thought process and we've decided that, yes, we do need to have an app that runs on multiple devices, whether it's one, whether it's two, or whether it's all of them. You find some challenges with this approach that you need to consider. First is one UI doesn't fit all, right? If you jump from even just the desktop space, even if you just look at the desktop space, you've got high-resolution 4K monitors, you've got small little tablets, you've got everything in between, right? The UIs are different. Then you consider Xbox, where you're building for a 10-foot experience, or you can look at IoT devices that might or might not have a screen. There's all kinds of UIs as you bounce through these devices. And if you don't do some of the things that we're looking at, consider some of the things I'll talk about in this talk, then what you end up having to do is, if you're targeting all these devices, you have to kind of target a minimum subset, something that will run across all of them, right? If you're not going to take advantage of hardware features on a device, sensors on an IoT device if you need it, various things that for the desktop, if you're not going to take advantage of those, then for each specific device, then what you're doing is you're having to migrate and condense everything down to this minimum subset. And the problem with that is you leave things on the table, right? Could you provide a better user experience for your users if you had kind of built that out specifically for that device? And so those are the kind of questions you have to ask. And finally, all inputs aren't created equal. It is a much different interaction building an app where you're using a mouse and keyboard than an Xbox controller. And I've done this. We've had apps that have run on desktop and on Xbox. There's so many more things that you have to consider. You have to consider things like how much data are you really trying to input, because it's a pain to input on an Xbox controller. Where is the input field on the screen? Because with an Xbox controller, virtual keyboard comes up, which means the bottom half of your screen is hidden. So if your input field is below the bottom half, you hide your input field. So there's all kinds of things like that that you have to consider. So the first thing we'll talk about and kind of go through is just the concept of responsive design. And not really caring which device we're on, just what the UI is and what kind of space we have to work with. And I love this quote and this concept because most of our apps that we build are content-driven apps. Now, there are exceptions, but most of them are content-driven apps these days, right? You are charts and data, social media, blog, videos, images, all this content is basically what you're serving up for your users to consume. right? So if you put water in a cup, it becomes a cup. If you put water in the bottle, it becomes the bottle, right? It takes the shape of its container. And our UI should do the exact same thing. If we are building out a UI for a desktop in a nice wide environment, why not use that space? Why not present more information to the user? Now, but if you go down to a tablet or a smaller device, though, what happens to that if you've designed for that nice big wide experience? What happens to it? Do you just cut it off and say, well, you know what? You don't really have the space, so we're just not going to worry about it. You don't get to see that stuff. Or do you redo the UI so that you reorder things, you move things around? This concept of responsive design has been around for a while, and it's mostly been in the web, and it's something that back in the WinForm days and really in the WPF days, we really just didn't consider all that much as Windows developers. So it's a new concept and a new thing to tackle for a lot of Windows developers who've been doing this for a while. So if you're going to go down the road of responsive design, you can't design something that hits every single possible combinations of your UI. So the concept that you go through is you find a couple of breakpoints. You either 2, 3, or 4, somewhere around there, you say, okay, look, we're going to go with a small, medium, large. If our resolution is this big, we're going to design for this big experience for the user. And we'll do the best we can to kind of adjust things along as we go. But for the most part, this is going to be the layout. Then when we get a little bit smaller, we're going to go this medium route. We're going to move some things around. Maybe we turn some things off that we don't think they need to see, or we just do some reordering. And then at the small, then we really have to start considering what data we're presenting. Can we present a smaller, streamlined version? Do we have to add more navigation? What we're going to do. So out of the box, we get a lot of help from UWP. And one of the things that I've really liked with working with UWP and with talking with the Microsoft engineers and such is that they do a great job with their controls and their platform of doing the things that you're supposed to do, right? Their controls out of the box are responsive. They're accessible. They do all the things that as your app should also kind of carry along. And so they help you along the way. And at some point you have to, there's only out of the box so much that can help, and you have to take these on yourself. But all the controls do a great job. And they do things like they adapt to size and they adapt to input type. If you're building a UWP app and you've got buttons and radio buttons and things like that on your screen, if you pay attention between a desktop mode and a tablet mode, the sizing of that will automatically change. Your hit targets will increase for touch automatically because that's your input has changed. So the controls take that type of stuff into consideration. And then all the the features of responsive design that you need to look for, where it makes sense in the controls, they automatically do it. They do repositioning, they'll resize. If you're a simple example is if you had a grid view and you had an image in that grid view, and as that screen size changes, that grid view container changes, that image will change size for you automatically. It will scale for you. Reflow, you'll see things showing high. We'll look at some examples here in a little bit, but this is kind of stuff you get out of the box. One thing in particular I want to look at was the relative panel. So we saw this in UWP, and it's another layout control. And instead of doing specific layouts and positioning, like in a grid, we define our columns, we define our rows, then we say, okay, look, I want this thing to go here, and then this thing is going to go over here, and this thing is going to go down here. It's going to span a couple of columns, and we kind of lay everything out that way. Well, if you're going through a responsive design and you've got your breakpoints that I was talking about, then what you end up having to do is between your large and medium and small, you have to really start reorganizing things. You potentially have to change up the sizing of your grid. You have to do a whole lot of work. Well, the relative panel allows you to place objects in the panel in relative relationship to other objects in the panel and then the panel edges itself. And the best way to talk about it is just kind of walk through an example. So here we've got 3 rectangles, the blue, red, and the green. Right? So we got the blue up there, just like all other panels. If you don't put any kind of positioning, it puts it 0, 0, top left corner, and that's where it stays. When it comes down to the red, we've got, we set our sizing for it, but then we do a relative panel and we do the right of the blue. So it's situated to the right of the blue. If we move the blue somewhere else, we added some padding to the blue or anything like that, it would move and adjust the red in relationship to it. Then you've got the green. And the green, we did a little bit more with this. We put it below the blue rectangle, so we want it down below. We align the left edge with the blue. So again, if we move the blue around, the green will move with it. And then on the other side, we say, okay, hey, you know what? We'll align it with the right-hand side of the panel. So it'll always stretch across the panel no matter what the positioning of it is. So if we go through, we move a couple of things here, instantly, which is a couple of property changes, we change up our entire UI. So we now, for the red rectangle, we moved it below the blue instead of the right of. Right now, since it's below, we need to move that green out of the way, so we just changed it and put it below the red. So with a couple of quick changes, all of a sudden our UI has completely changed. So if you think back to that image of basically the blocks in your UI screen where we've got multiple things that, and we want to change the overall layout, you can easily change the overall layout and containers of your UI just by using this relative panel. Another great thing that helps out when we start looking at responsive design is the VisualState Manager. And I love the VisualState Manager and the stuff that we can do with it. And primarily because I love my separation concerns and I want to keep as much things, design things and UI things in XAML as I can, and I don't like having a bunch of code behind stuff. And what the Visual State Manager basically does is it gives us the ability to define groups that if we set the state to that certain group, it will set the properties with either animations or just by setting the values. So we can have our UI and we can set different states, whether it's the size of the UI or some kind of interaction that the user's done, some kind of, the states, it's in an invalid state, it's, we need to light certain features up based off of the user credentials. We can do all that by just setting the states. You can set the states in code, and we'll take a look at how you do that. But this is a great way to kind of group all your changes. If you think about any type of a complex UI layout, if you're going to go this route of, hey, we're going to create a responsive design, and we've got these breakpoints, and so if we hit a certain spot, we're going to make all of these changes. You start throwing all that in code, it's hard to maintain. It's hard for people to track and see what's really going on, and it's very easy for you to mess stuff up. Somebody comes in XAML and changes something but forgets that code behind's got all this hardwired stuff in it, and things get kind of messy quick. So let's go ahead and take a look at the demo here. And there's a couple things that I want to show you. All right, so the first thing here is this screen here is basically three components. You have a navigation view, you have a grid view showing your containers, and then you have a command bar at the bottom of it. And I just wanted to show you real quickly, there's no code behind, there's nothing special outside of that, just some of the stuff you get out of the box. You see as we start changing the size, your navigation view automatically shrinks down for you as it starts getting smaller. Your grid view will automatically reflow your items to adjust for the space that you have. You'll see that our grid, at some point, we actually end up losing our navigation bar, and we can set that to where it just basically becomes the hamburger at the top. And you'll see here that we've lost some of our command bars, but instead of just cutting them off, it automatically puts in here instead of using it to it. So out of the box, these are some of the things I was talking about. So let's look at, let's go over here and look at this. So here's another example of UI that created out that has a little bit more components into it, and that we're going to do the responsive design ourselves. So again, you'll see that here we only have a single breakpoint, and at a certain point, a couple of things happen. One, all this block over here on the right drops below, and then you'll notice that here, instead of being spread out, our template drops to where we compact the data a little bit more. Now, if we come over here and take a look at what's actually going on here, you'll see in our relative panel, we've got things like we've got our title at the top. We have that image poster that sits below our title here. Then on the overview, it sits below the title and to the right of the poster. We've got the grid information with the release date and such. It sits below the overview. We set all this stuff up in code. Then in our code behind, we came through here. We registered for our size change so that we know when our page changes, and then we just write our code. So had a breakpoint at 600 pixels. At that point, if it breaks that, then we go through. If it's small, we go through and we just update all the items to see what we showed. We move the overview below the poster. We move the overview and the grid over to the left of the panel. We move the list of the cast to go below the grid info. And then we change our item template here to use that more compact template. And then if it's not small, then it just basically goes back and resets everything. Now, as you can see, for this simple example, we've got quite a bit of code here. And if you have an actual UI with an actual lot going on, this gets ugly quick. And that's just for 2 states. What if you have 3? What if you have 4? So then let's take a look at using the exact same screen, but let's take a look at using this guy here, our Visual State Manager. So we add a Visual State Manager here, and we added 2 states, just like we had in code. We have a wide and a narrow, and then we're doing the exact same thing. We're just setting these properties in our XAML versus having them in code, right? So the exact same thing going on here, the exact same UI. Now, if we go back and we look at our code behind, now we still have our size change that we're tracking here, but instead of all that extra code, all we're doing here is saying, look, if we're small, let's go to that narrow state that we had. If we're wide, let's hit that wide state. So now, no matter how many changes we have to have, this is all the code that we need, and our code gets much simpler, easier to follow, and we still have the same response. So if you come over here to this guy here, you'll see it's the exact same response. It's just doing all that in the code, or using visual states. So one other thing I wanted to talk about when we look at responsive design is state triggers. Now, state triggers are this cool little piece that got added in that allow you to basically write code that will trigger a visual state. So instead of having to, in our code, go say, hey, visual state, let's go to narrow or go to wide, we can create a state trigger that says when these conditions are met, enable this state. With UWP, you get there's only a single state trigger that shows up, and that's adaptive trigger, which happens to work out very well for responsive design. But you can there's a state trigger base that we'll look at later to where we can actually build out our own state triggers. So any logic, any workflow that you want to have, you can have inside of your state. And if you look at what here is, at this point we have a visual state trigger. It's the same visual state that we had just created, but we added a state triggers section, and we added this adaptive trigger that will fire off if you're less than that 640. So let's jump back over here real quick. And we have one more view of the exact same screen, but here we're using adaptive triggers. Right? So here we're saying if the minimum width is 0, let's go through and set this narrow state. All this exact same as we just saw. Then we have another one that says, hey, the minimum width is set to the static resource. Let's go to our wide view. And I put this in here for a reason. Yes, we could set the value here, but one of the things that we found when we're using visual states for responsive design is that if you've got a whole, dozens of pages and user controls and all this stuff that's using these breakpoints, and you've hard-coded in 0 and 600 everywhere, what happens when you have a design meeting and they're like, we really think that 550 is going to be a better number than 600 on this breakpoint? Then you got to go find everywhere in the code that you've got 600 in there and change that. And if you got multiple, then that's the same thing you have to do. So to fix that, in our resource dictionary for this app, basically I just threw up here a nice little integer that sets that. So now if I want to change that, all I have to do is go change that number, and across my app, it works. And so now the other thing to look at, which makes me very happy, is now here's our code behind. Right? We're set our view model. We're not tracking size or anything like that. Our UI has nothing in this code behind. All we're doing is wiring up our view model to our view, and we're done. Right? And that's always anytime I'm on a project, keeping these code behinds as clean as possible is my #1 job, because the sooner these things start getting messy, the more complicated your app gets and the harder it is to maintain. Every single time we run away with these code behinds, it just causes problems. It has every single time. So next you need to start looking at designing for capability. And what I mean here is we have a couple of things that are going on for us. With Windows 10, now we get major releases every 6 months, right? And every 6 months means we get new features. And new features come in the format of new controls, new APIs, new properties, new enums. The list, it goes on and on and on. So what happens if you've got an app out and the new features come out and you want to use that app, that new feature? You want to use that new control in your app, or you need that new API or property for some reason. Well, forking your code and having multiple versions every 6 months of your code base just so you can handle the new features that come out just doesn't make sense, right? So you have a couple of choices. Do you go through and ignore the new features until your minimum version you support catches up? Or do you isolate your people that are running an older user base, older versions of Windows 10? Well, the answer here is conditional coding. So with conditional coding, we've got the ability to go through and check these things in code, right? You can check to see if this new property is available in your version of Windows 10. If it is, then you can use it. If not, then you can go back to a fallback scenario. You can check to see if an API is available. You can check if this new enum is available and take advantage of it. And you can do all that, and it works great for that. The other thing it works great for is, we'll look at extension SDKs later, but with extension SDKs, we've got the ability of adding device-specific APIs into our code base that aren't going to work everywhere, right? If you've got Xbox-specific APIs or desktop-specific APIs, they're not going to work if you're on a different device. So you can use the same conditional coding to do a check just to see if those things exist. There's a little while back, we actually got the same type of logic, although a little bit smaller, a feature set to do it in XAML, right? So now we have the ability that we can use this conditional logic in XAML and change our workflow or change our UI based on what is available on the machine. And I'll show you a couple examples of this. Now, you'll see that the list here is not nearly as much as we had on the previous screen. You know, it checks for type and APIs and properties, but it doesn't check for enums, it doesn't check for methods, things like that, specifically because you don't really need a lot of that inside of the UI. But you can actually, if any of that stuff you did end up needing, it'd be easy enough to just create your own state trigger to put this logic in the code in your XAML yourself. So let's jump over and take a look at that. All right. So in our API demo, we've got two different things I want to touch base. We'll look at first here. So in our code base, our code behind here, we're going to use this API information as property present. And what this is doing is there was a feature that was added to the framework element, the allow focus on interaction, that basically allows you to override the focus on an element if it gets interacted with. The use case here is that we have a text box, and the user's entering stuff in the text box, and if they need to click a button for some reason, but you don't want the focus to jump to the button when they click on it, and it wants to stay with the text box, and you can turn that off. And so that's what we're doing here, is we're taking our button, we're saying, hey, look, if this is present and we can take advantage of this, then let's go ahead and turn that off for this button. So then when you come over here, and we're in our text box, and we're typing in data, and we come hit this clear, you'll see that our focus is still here. It's a great little feature to be able to use, but we only wanted to use it if it was available. We didn't want to, on versions that didn't support this, just not support that version of Windows 10 anymore for a feature like that. If you jump over to the XAML side of things, you see here we're using, it's a namespace. Basically, it's creating namespaces is how this works out for doing your XAML conditioning. So we have this contract 5 present, contract 5 not present. And what it's doing is it's checking to see if this API version, basically if this app supports, or this machine supports this specific, at least this minimum version of Windows, the Universal API contract. And the reason being is that there was new control in the version 5 of the Universal API contract, the color picker. So if we had an API before then that needed to select a color for some reason, you didn't have a nice little color picker control, you had to go with a third party, or you could do something like a drop down or something like that, or create your own. So what we're doing here is we're saying it twice. We're saying, hey, we're checking to see if it's present, and we're checking to see if it's not present. And the only difference here is you'll see that it's checking to see if it's present or not. And what that allows us to do in our UI is we're saying, hey, if it's present, let's use this color picker, because we want to use it. If it's not present, then we're going to come down here, and we're just going to use this combo box. And to take a little bit further, for our rectangle here that we're basically just setting the color for our selected color to, we can conditionally set the fill of it based on if what version of the API we're on. So if you come over here, since we have version 5 of the API contract, we get our color picker, and our binding works. Now, if we didn't, then we'd have a drop down, and when we selected the color in the drop down, it would change the color of the API. So we can take advantage of the new features that are available without having to go through and cut support for older machines. All right. So this brings us to device-specific UIs, creating a UI specifically for a certain device family. And the first thing that comes up is, why should we target these devices? What is it about these why even go down this route and worrying about it? Well, the first is just different hardware capabilities. If you're going to write a UWP app to run across multiple devices, you have to understand that there are different capabilities, different features that you could use, or just different specs on the hardware. If you write an app that's going to run on an Xbox and is going to run on a Raspberry Pi, that Xbox has a ton more graphics processing in it. You can get away with a whole lot more as far as creating this dynamic UI that when you dump the same app onto a Raspberry Pi, it's just not going to perform as well. So do you have a bad user experience and just dump it over to the Raspberry Pi and say, oh, I'm sorry? Or do you cut back what your UI does and take out some of the animations or some of the high graphic intensive parts of it? The user interaction, people just use devices differently. We talked about this earlier, right? You interact with an Xbox much differently than you do with a desktop, right? An IoT device, whether it's a touchscreen kiosk or whatever the case is, you interact with it different than you do with your desktop. HoloLens, you definitely interact with it differently than you use other devices. These are all things that you have to consider. And then simple workflow, it kind of follows along with that. You know, is our workflow, if we're going to interact with your app through a certain device, does it change? Do we want that workflow to change and do something different because we're on a certain type of device? So the first thing we need to look at when we start doing device targeting is setting it up. So if you do a file new on UWP, there's that nice little box you get at the beginning that asks you what minimum version you support and what the maximum target version you support is, based on what you have on your machine. And all that really does is it sets this in your AppX manifest. And so it comes out, the device family name is Windows.Universal, which means it will run on everything, and what the minimum it supports and what the max version is tested. So with this, out of the box, your app will run across all devices. You don't have to do anything. If it's set to Windows.Universal, it will install on every Windows 10 machine. Now, say you are building something for HoloLens, and it's only for the HoloLens. Well, instead of keeping that original Windows.Universal, change it to Windows.Holographic. That way, your app won't run installed on devices it wasn't built to run on. Because if you've got a ton of 3D stuff and all the kinds of, everything for a HoloLens, and you dump that on a low-end laptop or something like that, how's it going to perform? It's going to give you a bad experience. And then you're going to end up with deals with, if it's a consumer-facing app, then you're going to get complaints and bad reviews off of that, or you're going to have internal issues. And I know you might be thinking, well, if I built it for HoloLens, why install it on desktop? Well, it goes back to what I said before about the whole just because you can doesn't mean you should. And I promise you, if your app will install on a certain device, at some point, somebody's going to do it just because they want to see what it does. So if you allow them to do it, they will do it. You can also kind of really start fine-tuning this if you want to. If you want to target multiple devices, you can say, okay, look, I'm going to just support these devices, And the other thing you're allowed to do with that is you can change the min and max versions, right? So if there's for some reason you have a different minimum version of Windows 10 that you want to support on one platform versus the other, you can kind of change that up and manage it this way. So I talked earlier about extension SDKs, and some of the device families, they have their own dedicated SDKs. Not all the device families do, but some of them do. You'll find them for desktop and IoT, things, and Team for the Surface Hub, things like that. The interesting thing about these SDKs is they basically provide stubs out for all the platforms. So if I install the desktop extensions on my UWP app, but I still want my app to run on the Xbox, it will run. And there's stubs for those APIs that are there, so it will run. The only problem is if you try to call those APIs from the desktop or on the Xbox, it will error off on you because they don't actually exist, right? They're just stubs out there. Or it won't error off and it will do something weird, and it just depends on which API you're calling. So then it goes back to that conditional API that we looked at earlier, using that so that we can take advantage of these extension SDKs. The other benefit of kind of breaking this up is if you're looking at Windows 10 as a whole that's running across all these devices, we're looking at it going, hey, we want to keep this small, we want to keep it flexible. If we start building out all these extension SDKs and put them in the main platform, then the platform just keeps growing and growing and growing. And the more devices we add, the bigger the platform gets, and it becomes burdensome. So by separating them out, it keeps everything nice and slim, and you can use what you need to for those devices. It also kind of breaks it up and allows the teams for the different devices to release versions at their own cadence. Right? If it was all part of Windows 10, then it's a matter of, okay, we got to get these cycles into Windows 10. We got to make sure it gets all tested with Windows 10 and comes out through the main release process. Here, they can release it whatever their own cadence is. Now, for device families, every time you install a Windows 10, every installation of Windows 10 has a device family declared to it. Every single one of them, and it sits right here. It's a string value that sits in the Windows System Profile Analytics Info version info device family. And currently, this is what we're working with. So being a string, it helps you out because if, as new features come out, as new device families comes out, you don't have to worry about enums breaking or anything like that. But every single app, every single device will expose this. So this allows us to start really building out device-specific UIs, right? If we know this information, then we can design stuff for the Xbox, we can design it for the desktop, and we can put it all in a single app. So let's take a look at how we can do that. So there's a couple of things here I want to show you. We'll start over here in our root launch. So I've got 3 devices up here. I have a laptop, I have an Xbox One, and I have an IoT device. We're going to look at this app that's running across all 3 of them, as long as the demo guides will work with me. But the first things that we need to consider, and just to kind of show you some of the things that you have to consider when looking at different devices, is Xbox has its own quirks and its own things about how UWP app works on it that you have to take into consideration. So things like here, we're saying, hey, look, if we are the Xbox, there's a couple of things we need to do when we create our app. First off, we turn off the mouse mode. Using that mouse little cursor pointer in an Xbox app is very hard and a pain to use. It's a much better experience if you just use the navigation, basically using the tab settings in your Xbox, your UI, so you can use the controller to skip through it. And that being said, actually a subset of designing for Xbox that way that we found out, honestly by accident, the first app I did that targeted both Xbox and the desktop, is tab positioning for UWP projects can be complicated. When you've got so many nested controls in it there's the exterior controls, you don't want to take tab focus, and getting it all lined up to where the flow goes right so that if the user's hitting the right, it's actually jumping the parts you want and getting everything where can take some work and it takes some time. The benefit of it that we found out that once we got it all working for Xbox is that we wanted our desktop app to be accessible And by doing that, you add most of the accessibility things as far as being able to tab through your app in a way that makes sense. You've resolved that just by getting it to work right in the Xbox. But so what we're doing here is we're going through and we're killing the mouse input pointer so that it's not there unless we actually request it. And then we're disabling the auto scaling that happens. If you noticed, if you ever actually started doing pixel counts and stuff, you'll know that UWP apps, depending on the platform, default to 150% or 200% of the scaling, just to get things kind of expanded out there for you. And it also depends on the size of the machine. With Xbox, the problem you have is Xbox already does the scaling for you outside of UWP. Xbox, basically, it presents an HD picture, and it will scale to the device accordingly, but everything in Xbox is all about that HD resolution. So that allows you to, when it comes to responsive design and things like that, if you're just targeting Xbox, that makes your world easier because it's always the same resolution, and Xbox will scale that. So what we do is we turn off the auto UWP scaling because it just gets a little wonky sometimes when you're dealing with the two of them. Other thing we're doing with Xbox here is with Xbox, since it's running on TV, there is this concept of overscanning. And some TVs do it and some TVs don't. So what happens is if your TV doesn't support overscanning, then you end up losing the outer edges of your view. So by default, what happens on a UWP app that runs on Xbox is they just put a margin around it for you to create that TV space, safe space, which is great for TVs that don't support overscanning. But if they do support overscanning, then what you end up is with a nice little border around your app, which you can live with that in some cases, but the other cases, like if you've got a list scrolling that I'll show you in a second that's scrolling off the screen, all of a sudden it's just getting chopped, and it has this real weird, funky scenario. So since we're going to do that, basically we're turning off that auto scaling for it so that on the Xbox we're using the entire window. And the last thing here we'll show you is I've got some code here for our IoT device that says, hey, look, if we're on IoT, we're going to actually change our workflow. I told you sometimes we have to change our workflow depending on our use case. And we're going to basically just navigate to a different page. And we're going to go to this kiosk page that we created instead of the main page for all the other devices. So let's come over here. The next thing I want to show you is, before we jump in our XAML, I told you you create your own state triggers. Well, this is how to do it. You inherit off the state trigger base, and we've created one for a device family, and basically it's got a single property in it. And what this does, it says, look, we're going to set this trigger active if the device family that we set in for this property is the same as what's on the device. So when we come over here to our XAML to take a look at how this looks in action, we're using our state triggers here, and we're saying, hey, look, if we're on the desktop, let's do this other stuff. If we're on Xbox, let's change these things up. So these will get fired and activated based off of the device that we're on. And here what we're doing is we're basically just changing a watermark that we have up here at the top. So let's take a look at this in desktop. So for our desktop, see the watermark here, it shows it's desktop. You'll see our image here comes all the way to the very edge of the app. We've got our list view over here. Very simple, kind of a straight layout. So let's go take a look at the same guy over here. And it's hard to see in here because the scaling is turned off, but it says Xbox up in the left corner for our watermark. But let's see here. We've got, since we've turned off our edge, and I don't know how it's going to work on a projector, it'll actually scroll through the top of the TV. So that gives us the ability to have a nice fluid experience for our users, and that's different between the two devices. Now, if we jumped over to our IoT device. So our IoT device, I already have it launched. And so I have this kiosk mode in an IoT device where basically instead of allowing the user to select which video they want to watch, assuming they're videos, it's images just for the purpose of demo, it's just basically going to rotate through the videos. So here we're just on a timer and stuff. So this is a totally different page that gets called based off of the fact that this is an IoT device. And it's the same code base, it's the exact same app that's just been deployed to all these devices. So basically there, this kiosk video came through, and that's what's being used. All right, let's see here. So one of the last things I want to talk to you about is using different XAML for different devices. So this is kind of a cool little feature that if you create the state manager like I showed you, it works. And one of the things we found, though, when you do that is for the app I had, the big app that I had this, we probably had about a dozen views. And the views were littered with state managers in there and code behind stuff to try to get everything tweaked out for the individual devices. Well, one of the things you can do is there's a naming convention for device families. And the interesting thing about it is when you look at what happens when you compile a UWP app, the code behind your classes get built out, and then all your XAMLs just basically get stored in the UWP as a resource. So what's happening here is they're allowing you to use a naming convention to say, all right, so for our main page, we have our code behind, our class gets built and compiled, and then our main page.xaml gets stored in UWP as a resource. And so whenever the app pulls up that page, it pulls that resource out, and it does what it needs to do. So if we use this naming convention of main page.deviceFamily-desktop.xaml, all that happens is if we're running on a desktop, it will actually pull that resource out and use it with our code behind. Now, the code behind the class doesn't change, right? So if you are going to build different versions of your XAML, it still has to have a shared code base. So any controls that are in your specific device families has to still be in your code behind so that it knows about it or error off because it won't know about the controls. This works great for resource dictionaries. So you can have your own resource dictionaries for an Xbox, for desktop, and a lot of the stuff that we had commonly across a bunch of the files, like margins and spacing and all the various things that changed between the Xbox and desktop, we were able to just put them all in their own specific resources, and it pulled it just without having to write any code to switch between the resources. So I showed you this real quick, and just kind of what this looks like. So we're see here in our device family, so our resource group is just, I've got this resource dictionary called dictionary, and it just actually gets called right here. We just create it here. Now, I also have this device family-xbox, and what this does is, and here it basically just sets a single property and just sets some padding. And if you'll remember, since we turned off the TV safe margins so our list view would work right on Xbox, the problem we did with that is our main view of that bigger image is going to be off the TV space safe area. So all this does is use some margins to kick it back over to where it's nice and safe, so if the TV doesn't support overscanning, then it will show up right and not cut things off. Now you can do this at the file level or you can do it at the folder level. So here is our control that we are using for that main display piece, and it's got the image and it's got a text block. If you look here, we got our title here and our image. What I did here is just create a folder called device family-xbox, and every XAML that falls up underneath there will get used as well. So that way, if you've got a whole bunch of views or a whole bunch of controls, and you want to replace several of them instead of littering the folder with, main page, with the desktop family Xbox, with desktop, with all this kind of stuff, you can group those all in the file folders. And again, same stuff just works here. And if we jump back over to this guy here, you'll notice here that we don't have the title below this because it's using that custom Xbox that we have, and our margins are a little bit different so that we can see that. And some of the things one of the other things when you start looking at going across devices that kind of jumps out sometimes and gets you is by default, UWP is in a light mode for your apps, right? You go light setting. You notice here, Xbox dumps out by default to the dark setting. So there's no difference here, but between the code bases. But here we're dark, the one that sets the light. So you'll find when you start bouncing between devices, if you want to create a consistent user experience, there's a little bit more work you have to do because you end up taking for granted at times. It's kind of some of the default features for one platform, and then when you move to another platform, those defaults have changed, and that will sometimes come back and get you. Come over here. All right, so UWP on multiple devices. We broke it down into 3 categories: responsive design. And the thing about this is, if you are building UWP apps just for desktop, the responsive design is important. I don't care if you're not targeting anything else, you need to handle responsive design. If you're doing just for Xbox, let's say you don't have to worry about it because there's not that need for it. But if your device that you're developing for has the capabilities to have multiple size resolutions and stuff, responsive design is important. Designing for the capability really allows you to target multiple devices or multiple versions of Windows and taking advantage of the latest and greatest without having to orphan your users. And then creating design-specific UIs so that it looks and functions right across the multiple platforms. It's very important. With that, that kind of wraps up. This is how you get a hold of me. There's my email address, Twitter, blog, these samples up here. They're on my GitHub if you want to take a look at them. If you have any questions about any of this, you want to talk UWP, you want to talk WPF, you want to talk about anything dev, I'm always up for it. Feel free to reach out to me. I think with that, that's all I got, unless there's any questions. I know we have microphones if you want to use them. Got any questions?
So you talked about checking for capabilities for different versions of Windows and so forth, but with the new Windows UI stuff that's supposedly going to get separated from Windows and you ship it and it works on a bunch of different versions of Windows, does that change or?
Well, so that changes from the UI standpoint. So yeah, so when it splits off, as the WinUI, once you start switching over to WinUI, from a control standpoint, yes, that changes. But from an API standpoint, that doesn't change because the APIs, there are still tons of APIs that are not UI focused. That the same kind of functionality and stuff that you have to do that conditional programming with.
So if you're doing something like C++, in order for it to, because you have the check, but then you're going to have a piece of code that might be dead code, but it's still going to be there trying to call that API, or all those bindings kind of dynamic or otherwise?
Yeah, so the problem you have with conditional coding and stuff like that is that at some point you'll have dead code. At some point everybody will catch up. So there's certain tech debt that you automatically inherit with that. And that's just a process of managing your tech debt, that at some point once your versions, people roll up to that version no longer matters, then you can go through and clean that up. That's just kind of one of the natures of it.
I was sort of asking, I guess, the opposite question, right? So if you've got the latest version of Windows has a new API, and you call and say, am I on that version? And you get back the answer is no, you're not going to call that API, but that API is still in your code that's trying to get resolved at load time. And I was asking if how you manage that. Gotcha.
So the way that those APIs work is it's all stubbed out. So that if you only run into problems with some of that when you end up, there are certain features, and most of them are UI, that you can't do that with, just from the standpoint of, you'll find the navigation view. It will only go back so far, and you can't break behind use a navigation view in your code if it's not supported further along. But for the APIs that aren't being, for that API information, since it's not being called, it skips over that process altogether. You don't have a problem with it airing off. It's just part of the way UWP is set up. So that specific call with that API deal, when it builds it out, it doesn't actually put that code base into the call, isn't being used on the older versions.
So it's not like trying to load an XE that has a unresolved import out of a DLL.
Correct.
Okay.
Correct.
I had a quick question, just related. The example you had with the color picker, with the newer versions of Windows, people are going to get the color picker, and you had the example where it was the combo box. So right off the bat, I can see this happening where you have one user that's really old, and you've changed code, and for whatever reason, they're saying they get the color picker with the combo, and they select it, and for whatever reason, it doesn't work. Is there an easy way to turn that on? Because as a developer, I'm probably using the new version of Windows, and I've kind of forgotten about that feature.
So yeah, so the best way to test it is to change you can change in your debugging the version that you're testing on, and you can go through and change your version. So as long as you have that version installed on your machine and you've got the SDK for that version, you can actually go back and test for those various versions. So if you actually want to test for that, we could have gone through and just changed the SDK version we were targeting, and then we could have tested that to make sure that that experience works the way we want it to. So it's a little bit of work, but it is testable.
Thank you.
Yep. Cool. Well, I'll be around here for a little bit because I've got like 100 machines to tear down, so feel free to come talk to me. Other than that, hey, I hope everybody has a great rest of the build, and thanks for coming out.